Okay, let's have a quick read of this question. Key thing about this question is link it up, and I've noticed that it's very similar. These questions are coming up, and pick out the keywords and set it up. 7 marks, so you should get a standard 4 marks for just setting things up. So Pierre's a chef. He claims 90% of his customers are satisfied with his cooking. Yvette suspects Pierre is overconfident about the level of satisfaction amongst his customers. She talks to a random sample of 15 of Pierre's customers and finds 11 customers say that they are satisfied. She then performs a hypothesis test, carry out the test at 5% success level. Now, first of all, let's set this up. So what we got is Pierre saying 90%. So you could do this 2 ways. I'm going to use what it is. I'm going to use it as a binomial. Okay. So we saying that let's call x equals number of satisfied customers. Number of satisfied customers, and Pierre reckons the probability that satisfied customers, the proportion of them, is 9. Let's do that. So satisfied customers is 90%, 0.9. Okay, so let's just write here we've got a null hypothesis that we say the probability of satisfied customers, proportion of satisfied customers, is 0.9. Now Yvette reckons he's overconfident. Okay, so she reckons that the alternative, she reckons that P is less than 90%. So just to put that out there, that is overconfident, so it should be less than 90% of people are satisfied. Okay, so you're going to get 1 mark, 2 marks there. You then state, and I think it is, well, I would say that you could say that x Trudeau's binomial, and she's going to choose 15 people. Okay, and she's going to test it with whether 0.9 is the correct one. Okay, and we can also state that it is going to be a one-tailed test at 5%, and it's important just put that as 0.05 significance level. So you're just setting it up at the moment, getting most of your marks in there, and then she wants to know probability that finds 11 customers are happy. What is the probability that x is less than or equal to 11? That's what we need to work out. Now, when you're doing binomial, I would like to, because we're talking about whole numbers here too, go onto binomial list. Okay, so go onto your calculator, choose binomial. Now, before we choose anything, let's just draw this table, because the calculator will give you this table, and we need this is n, and probability of x is less than or equal to n, how many there are. So let's put all those numbers in. Now, I haven't done this, so I'm hoping you're not going to help me out here. So this is 7. So we're going to produce a list. We're going to do a cumulative list, not PD, cumulative list. So that's going to be 1, and I'm just going to put the list as 1. So here I'm going to put few values here. I'm going to put in starting from, let's say, 8. So we go 8, 9, 10, 11, 12. Let's put these values in. Probably didn't need to put that many, but it's easier to do them now. Then we can just pull them all out. 10, 11. Oops. Okay, and 12. And then n is 15. and the probability is 0.9. So if you got your table, which mine has got, probably that will be less than or equal to 8, that is 0.00031. This 9 or less is going to be 0.022. Next one's going to be 0.0. So it's going to 127, and then 11 is going to be 0.0555, and the next one, might as well put the next one down to going to be 0.184. So probability of getting less than or equal to 11, less than or equal to 11 is equal to 1 minus no, we don't need to do 1 minus here, sorry. Just say probability x is less than or equal to 11. This already does the cumulative for me. It's going to be 0.0. Actually, I could have just put it straight in. Looking at it would have been easier. 553. Now that probability is greater than 0.05. Okay, just so in this case you must say, because that's more than that, therefore cannot reject the null hypothesis. Okay, so you already got 6 marks up to the right, and then you say that there is insufficient evidence to suggest what should we say that it's not satisfied, to suggest Pierre is over confident.